So what works when somebody is able to yo-yo is different than if somebody's entire body is now stuck in sort of a weight loss resistance capacity. Welcome to the Menopause Mastery Podcast, a show for women just like you who are ready for more health, vitality, passion, living life with a purpose. I created this show because I knew that women just like me in this second season of life, the season of menopause, are really tapping into their deepest desires. And we're ready to harness our physical and mental health and explore what our true passions are and peel back the layers to uncover exactly what we want out of life. I'm your host, Betty Murray, part geek, part magician, and your new medical bestie with a dash of sass. I love taking the complex science and making it easier to integrate into daily life. So let's join the journey to make this season the best ever. Welcome back to Menopause Mastery. So today I'm going to do a deep dive into weight loss resistance. And we're going to go into a deep dive because I want to clarify how somebody might get stuck, particularly on a plateau. And often this plateau could be your high point. Right? This could be the number, your absolute, the number that you're like, I don't want to be at this weight, but somehow or another, I've made it there and my body wants to stick and stay. Or it could be that you have tried to lose weight and you get stuck on a particular plateau and you can't get off of that. And especially if you've been there for a while. And it differs from yo-yo, weight gain, weight loss, in that the metabolic effect of what's really happening in the cellular mechanics are a little bit different. And how you have to address it, which is what I am very interested in, obviously, and how I work with my clients and patients in my clinic and also online in my programs, is that we have to understand where somebody is on this continuum, because how you address these things therapeutically in diet is different. So what works when somebody is able to yo-yo is different than if somebody's entire body is now stuck in sort of a weight loss resistance capacity. All right, so let's get into it. All right, so let me clarify the difference between weight loss resistance and yo-yo ability, right? We're going to call it yo-yo ability, right? So yo-yo ability is probably something that you've experienced. It's something that I've experienced all the way since probably my first diet at age 12, meaning that I could change some activity, whether it be caloric deficit, whether it was appropriate or not, or whether it was, especially back in those tween years, done in a stupid way that really probably wasn't healthy, or whether I, did a Weight Watchers, or I did a paleo diet, or I removed carbs from my diet, or I did a high protein, low carb, or maybe back in the 90s, you jumped on the low fat bandwagon, or you've done keto. Whatever that dietary intake that changed from what your normal standard diet was, created a weight loss, right? So in the person that will actually move the needle, they still have some metabolic capacity to lose, right? So they have a metabolic capacity to lose, and often they may lose to a particular point and they get stuck. Now, the reason why they might get stuck is because the diet created a metabolic effect that slows the metabolism, and then they sort of get stuck on this new metabolic rate that is lower than their original rate. So that's kind of your body's ability to sort of turn the engine on and burn your fuel, right? So inappropriate dieting, especially, and or inappropriate exercise can result in short-term weight loss, but it can also result in metabolic damage when done improperly. So the person that's able to actually lose in the beginning, right, they have some metabolic flexibility, not a lot, but they have the capacity to lose. What I'm going to talk about today is the person that is stuck. Right? And I'm going to give you my story. So I have never, ever been naturally thin, except for when I was a small child and I was underweight and under tall. And I'm still under tall. I'd like to use it that way. I'm under tall. I'm not even quite 5'3". But I was premature, right? And we know even people who are premature, babies that are premature, have metabolic changes in their body that increase their thriftiness, or their body's ability to store fat. Statistically, there's some really good research out there looking at that if you're premature, there's a little bit of a metabolic effect of, basically, my version of this is I didn't get to bake in the oven long enough, and I spent some months in NICU. But up until I was in my like tween ages, I was undersized to some degree, and it mostly was a height factor than anything else. But as soon as my hormones kicked in, I like to call it TNA. Everything sort of showed up at the same time. I got a booty and boobs at the same time, and they were dramatic. And that's probably the first time I actually went on a diet, was probably, that fifth, sixth grade, somewhere in that tween time period where I didn't look like the other girls, in my head. I wanted to have long, coltish legs and have that ballerina kind of body. And I was more like a Kim Kardashian sort of body. Maybe not quite as dramatic as her previous or the last, years after plastic surgery, but I was definitely, I had a little bit of a badonkadonk butt. So that started my dietary changes. And then through my teens and 20s, I did everything, so if there was a diet, I did it. I did early on in my middle 20s, get into bodybuilding. And at that time, I probably did my more severe restricting, where I was eating very low carb, eating very, very high protein. I was very consistent in the gym. I was working out at least 6 days a week. And in most cases, I was lifting weights, and my cardio was very, very limited, except for when I was trying to kind of diet down. But at that time, I was able to lose. Right? So I was able to do something, whether it was increase my physical activity or change my diet, and I could get weight to come off. It wasn't easy, but I could do it. Now, when I hit my 40s, and if you've listened to my other podcasts, that's when all my hormonal stuff started showing up. I started looking hypothyroid. I was losing my hair, and I had periorbital, which is a fancy way of saying, I called them Budweiser lizard eyes, because I would get very swollen around my eyes, and my ankles would swell, and my skin was dry. And so all of the things that was obvious for thyroid. And then I also started getting acne on my chin and along my cheeks, which is a sign of hormonal imbalance. And so I started entering what now I understand was early perimenopause, when I sort of exited my 30s, my late 30s, moving into my 40s. And at that time, all the things that I used to be able to do, i.e. go to the gym, lift heavy shit, and, eat high protein, low carb, all of a sudden failed to work. And really over a short period of time, I gained a lot of weight. I gained 35 pounds on somebody who's less than 5'3", who is a stocky girl to begin with, right? So it was disturbing to me. And also at this time, I was already in school as a nutrition professional as this sort of started, and I had started my private practice. And so to be working in the functional medicine and nutrition arena, with a certification and a master's behind me, I was like, how is this possible that I'm doing all the right things based on the biochemistry that I'm reading, and it is not working? And so for a decade, I didn't work with weight loss, because I was like, why the hell would I be trying to tell somebody what to do when I obviously can't figure out my body? Which started my journey on sort of this has got to be your thyroid problem. So I've been on the thyroid journey, and I'm not going to dive into that today, because actually weight loss resistance often has very little to do with the thyroid when we're talking about the cells. So I hit this plateau at way over 35 pounds, at least over what I am today. So, at my leanest, that was 50 pounds over what I was at my leanest when I was bodybuilding. So, and that is always a point in time. If you've ever been around bodybuilders, they get to a particular one when they get on stage, and that's that moment in day and time, and they are only at that weight at that time, because the dietary changes you do to get on stage are extreme, and they cause damage. So I have been on this plateau for 10 years. And, I went back to school. I really looked into the research, what I'm going to share today, and I was able to get off this plateau, and I've been off of it for more than 4.5 years without heavily restricting, and I work out less today than I have at any given time in my life. I'm very targeted about what I do, but I am not burning it off by spending hours in the gym. So let's get into what was really going on in my body. So the first thing you have to understand is that the body is designed to conserve. Our bodies, particularly female bodies, because nature cares about our capacity to be able to reproduce and procreate, right? So we are hardwired to conserve energy when necessary, to allow for reproduction and continuation of the species. And then, there was a concept years ago of the thrifty gene. Now, the thrifty gene fell out of favor because it's not one particular gene, but it's a constellation of genetic mutations that have happened, many of which are all humans have. And then we have some other unique ones that if you won the genetic lotto, that your ancestors probably had more scarcity than others, you probably have some other genes that sort of compound that capacity. So there is a thrifty set of genetics And all of us have some piece of it, but some of us are more thrifty than others. And if you've listened to my conversation with Kashif Khan, which was one of my very early episodes almost 2 years ago, you can understand that I have a whole lot of thrifty genes. So it made sense, right? Now, why would our body be designed to do that, right? Why would our body be designed to keep excess body fat? And again, it's because our ancestors for millions of years, and even if you go back to before we were human, we were more like ape-like. We went through a ice age, the last ice age, as non-human, primates. And what happened is that the ice age was so dramatic that the ice shelf basically moved through Europe. So the great apes that had migrated into that environment went through a massive genetic mutation. And what it allowed them to do was, number one, consume fruits and things, because that's what they ate, right? Consume fruits that were spoiling, right? So their sugar content was very high. They were fermenting, i.e. creating alcohol. And before that, if they had eaten it, it would make them sick, right? And so there was two major shifts in our genetics at that point. One is the uricase enzyme, and that is a change in the metabolic function. And then the other one is a fructokinase enzyme change that allows the body to basically manufacture fructose in the body. And this is one of the underlying mechanisms of why we get weight loss resistance. So you just want to remember that as humans, we went through these massive changes genetically. And it's what allowed apes to survive. And then we went through our ongoing sort of evolution and became humans. And then in that time, the ApoE gene kicked in, which is associated with hypercholesterolemia, so excess cholesterol, and Alzheimer's. And that gene allowed for us to have a greater inflammatory response, which allowed our ancestors to get out of the tree, walk the ground, and start to hunt, right? Where they were going to get hurt, they were going to get more exposure to infection, and then they were going to more likely die from those if they didn't create a better inflammatory response, meaning a more acute inflammatory response. So you just need to know at this point, we are wired to do this. So when we get weight loss resistance, and this means unable to move the needle in any real dramatic way, or maybe it might go 1 or 2 pounds, but man, as soon as you have anything to eat, it bounces right back. What's really going on? So it's very interesting when we look at starving populations. So at different times in different countries, and even in the United States, there are populations of people that do not have enough access to food, and they are starving, right? So many places in Africa, we see this consistently. What is really interesting is if you look at the research and dig into what's happening in that population, is they exhibit the same biochemical response as metabolic syndrome. Right? So anybody who doesn't know metabolic syndrome is the constellation of abnormal glucose metabolism. So you're going to see a higher post-eating blood sugar rises, so blood sugar is going to climb more quickly. You're going to see a higher insulin response. We're going to see changes in lipids, so you're going to see things like your cholesterol climb. You're going to see an increase in body fat deposition, so body fat deposits in places that we're not really designed to put fat. It's called ectopic fat. And that's when we start putting fat in places like the liver, the pancreas, the heart, in organs. That's not a normal place to store fat for later. It's normally we would store fat as jiggly bits, particularly as women. We're going to store it in our subcutaneous fat, which is the fat on top of the muscle, which is not damaging. So starving peoples actually have increases in ectopic fat storage, right? So we see all this kind of hallmarks of sort of pre-diabetes in starving populations. So that seems very strange because we've always been told that pre-diabetes and diabetes is because of eating excess food and lack of caloric utilization, right? So lack of use of calories and eating too much food, which absolutely can be true. But we see the exact same biochemistry in starving individuals. And what we really see is this is coming down to several things. So this is a starving cell. So the take-home message here is the cell is starving. And what's really happening is it could be severe caloric deficit. So in these particular cases where people are starving, they're not getting enough food that result in oxidative stress, so the body starts to rust more rapidly. We see mitochondrial dysfunction, cellular dysfunction. Your powerhouses are downregulated, and I'm going to explain each one of these. Often we're going to start to see sleep problems, right? So we're going to see sleep issues. We're going to see hormone changes like adrenal hormones, like cortisol, climbing significantly and staying high. And we also see things like triglyceride changes. You can see an increase in triglycerides despite the fact that somebody may not be eating a lot of carbohydrates. Blood pressure may change also, so we might see increases in blood pressure, which is basically the body's ability to create more perfusion. So it makes the pressure on the blood vessels go up by constricting, which allows more pressure. And we're going to see all these features that occur in somebody who's pre-diabetic or diabetic, but the person is starving, okay? So I'm going to explain that mechanism. So if you are stuck on a plateau, your body thinks it's starving. So the first thing you have to understand is, and I understand this because I was fighting my own internal sort of dialogue. The first thing most women will do is restrict more. It's like, okay, if I eat 1,600 calories a day and I can't lose weight, I'm going to drop to 1,300 calories a day. And if I can't lose weight on 1,300 calories a day, now I'm going to go to 1,000 calories a day. Or I'm going to go to 1,000 calories a day, and then I'm going to try and fast for one day. And then when I do that, I overeat because I'm starving, because I can't beat that biological pressure. And so we keep pulling back and restricting more. Or we go to the 90s sort of effort, which is we go, I'm just going to do more exercise. Because I hear this all the time. I talk to my female clients all the time, and we hear it in our hormone reset group all the time. It's like, well, I just need to work out more. I just need to work out more. I need to get on the Peloton. I need to work out twice a day. And that's not going to help either, right? Because it's just going to perpetuate the hormonal message that tells the body you're starving. Okay, so what's the underlying mechanism when we are weight loss resistant? So we have to understand that this is a cellular response. This is a starving cell response. And the generalized energy deficit that's being created is your cell's starvation response. So what's happening inside the cell? So when we are not getting enough food, for especially a prolonged period of time. And what you have to understand is it doesn't matter whether that's true or not, right? If your body is getting the food message that you are not getting enough food, it's going to drive this message anyway. So if you've heard my conversation about uric acid before, that is a big part of that. If we're eating a lot of the new crap that has been put into our food supply in the last 50 years, we are eating things that tell our body that we are starving. So the uricase enzyme that kicked in, that allowed us as our ancestors to eat fruit when it was fermenting, what it allowed us to do was consume large amount of fructose. When we consumed as apes large amount of fructose, what it did was raise uric acid in the mitochondria, reducing the production of ATP, which is your energy molecule, and slowing the metabolism at the cell itself. This is a starvation response in its complete entirety. And it is the same thing as the hibernation response. This is the same mechanism that allows hibernating animals to function and go and eat a bunch of fruit and other things and then go sleep for 4 months in a cave while they're waiting for winter to go through. So in the mitochondria, we get a starvation response that drives uric acid up, that slows the engine down. At the same time the production of ADP goes up, ATP goes down, we also get more lazy, right? And I mean lazy in that there is a metabolic effect that drives a lack of energy utilization. So the other thing that often occurs is we get more tired. We don't feel good. We don't feel like it. So we're like, oh, I'm exhausted. So I then probably reach for more stimulants and other things, and the body's going to conserve. So the two things that happens when uric acid goes up is it slows your engine and it slows the impetus to get more energy moving. Right? So uric acid is the driving point behind that inside the cell. When uric acid goes up, it slows the energy production. We start getting fat deposits on our liver and other organs, which then impair those organs' function. So let's get to the hormones. When this starvation response kicks in, we get several changes to key metabolic hormones. Number one, your thyroid conversion of T3, so that's the active thyroid hormone, is going to be severely impaired. And even if you're taking thyroid medication, you have to understand the body's going to override what's in the bloodstream to conserve energy. So thyroid is going to be impaired. T3 production is going to be impaired. T3 utilization at the cell is going to be impaired. And the reason why is your cortisol, which is your stress response, is going to skyrocket. Because cortisol in the natural world is the body's attempt at telling an animal to forage outside of normal foraging times. So if you see, animals foraging that usually eat at night or out during the middle of the day, they're either rabid or they're starving, right? So they are out because cortisol is up, telling them to search for more food. Now, cortisol goes up, metabolized cortisol is going to go up, and then that's going to block your thyroid receptor on your cells and turn down thyroid function despite the fact of having normal thyroid levels. But often the production of T3 goes up. And one of the things that you can find in people that may be inappropriately fasting or doing too much of it or not doing the right kind of fasting for them is you'll often see a major suppression of T3. And anybody that tells you that's a fasting, I'm putting air quotes around this, expert, that says long-term fasting doesn't do that obviously hasn't read the research, because it is part of that mechanism. And it is actually advantageous to create variability here for a short period of time. But if you're doing this in the hope it's going to create more fat burning, you're wrong, right? So cortisol goes up, thyroid levels are going to be impaired, whether it's the conversion of T3 or the active T3 at the cell. Now, because cortisol is up, we are going to have more insulin resistance. And when we do eat, we are going to have a rapid fire insulin response. So your insulin could be very low. It is routine for me to see a very low fasting insulin in women struggling with this because they are restricting so severely that their insulin could be a 1 or even a 2 in the morning fasting. So, every doctor go, oh, your insulin's almost too low. I'm like, no, it's low. But what I want to see is when you eat, what it does. Because if you were to take somebody and have them eat and check their insulin an hour later, 2 hours later, or do a full glucose insulin tolerance test, which is 3 hours and you check every half hour, what you will often see is you get a skyrocketing insulin response. So it is rapid and way above what's necessary. So then the body stores fat first. It says, okay, I'm going to take every carbohydrate and I'm going to drag it to the fat cell as a triglyceride to store. I'm going to preferentially put that in places like the liver, which is going to make the liver less capable of doing its job. Okay. And I'm going to get greater fat storage. So we have to pay attention to those hormones and understand that those hormones, particularly insulin, is going to drive that response. And I don't care how low you are in the morning, it's more important about what your body does when you make it, right? And if it's way above what it's supposed to be, you are insulin resistant. And just doubling down on diet change may not be enough because we have to figure out why. So insulin resistance drives that. Now, when we're insulin resistant also, the second thing that we see in metabolic syndrome, and we also see in starving people, is we see an increase in glucose in the bloodstream when available, right? So glucose is going to skyrocket too, so therefore insulin's going to grab it. We see an increase in serum-free fatty acids, right? So your body has mobilized fat. It's mobilized fats, put it in the bloodstream, and we see an increase also in serum amino acids and plasma amino acids particularly. So we're going to see, if we were to check your amino acids in the plasma, we would see an increase particularly of the ones that are glucogenic. So your body can take protein, either your muscle tissue or the protein that you eat, and it can take the vast majority of those amino acids and convert it into glucose. Now, this is part of the reason why I wanted to have this conversation, because a lot of my colleagues that work with people are telling them to eat really large amounts of protein, which I'm all for if you are metabolically sound, right? If you have good metabolism and you want to get more muscle mass, then eating 120 grams or more of protein is important. And when we're talking about somebody like an older person holding on to muscle mass, or somebody who is sarcopenic, meaning they're under lean, they've got too much body fat and they're lifting weights and they're not overweight, right? And especially they haven't been obese or overweight for a long period of time, they don't have, their mechanism still works here properly. But what the research shows is if you've been overweight or obese, and obese is when your BMI is greater than 30, right? So 30 and up. So if you've carried a lot of body weight for a period of time, the mechanism of amino acid metabolism has been radically altered. And I'm going to do a show on this, so I'm going to go into detail, but I want to just hit it today because it's important. So people who have been overweight get primed for their body to use the amino acids from their body tissue, muscles, and from what they eat as fuel. And what happens is your body will take the protein that you eat, take it to the liver, and it's going to use glucagon, which is the hormone, to go through gluconeogenesis and turn it into blood sugar and use it first. And it is aberrant and abnormal in people who have been overweight. And that's why somebody who is your trainer, who's 35 years old and has always been thin, can do 200 grams of protein and lose weight. And that when you do 120 and you're having 50 grams net carbs during the day and you're starving and you can't lose weight and you can't figure out why, that's probably why, because your body has turned on this mechanism, and it's called fueled partitioning in biology. And it takes a while for that to get reset, and it has to be very particular how you do it in order to tell your body that it's no longer starving. And it is different in somebody who's been overweight for a period of time than healthy populations. And you have to understand that when you read the research. So if I cherry pick the research and look at the ones that agree with what I think, I might overlook the fact that it is different in somebody who's been overweight. This is what happened to me. That used to work for me, but I spent a decade overweight. And so when I doubled down, it didn't do a damn thing. So when you have been overweight for a period of time, your body can also preferentially basically use your proteins as glucose. And again, that's our body's ability to conserve. It's trying very hard to use the fuel it can use and hold on to body fat. So now we've got the thyroid, the cortisol, and the insulin all basically leading you down the road to holding on to your weight. You've got the powerhouse inside the cell through the mechanism of uric acid that is now basically slowing the engine itself. At the same time, your fat cells are producing massive amounts of things called adipokinins and cytokines, which are inflammatory messengers. Some of them aren't, but the majority that are being produced at this moment are now inflammatory. And what they're doing is they're driving the insulin resistance and all the other things, because the more inflamed we are, the more insulin resistance we get. And we're going to have an immune response and an inflammatory response that's going to drive oxidative stress. So oxidative stress is the act of the body resting. Right. So if the body is resting rapidly, it's going to affect the powerhouse, but it's going to affect cellular aging. It's going to damage the cell membranes. It's going to damage the mechanics inside the cell. And if I have a high amount of oxidative stress, what's going to happen is, think of it inside the cell. So inside the cell are mitochondria, are power burning plants. They're coal burning plants. And so when I've got high levels of oxidative stress, it's like the coal burning plant is producing a ton of smog. And the glutathione, the superoxide dismutase or SOD, catalase, our internal antioxidants are there to sort of clean that up. Well, if I have oxidative stress because I can't do that, because I have all of this inflammatory response, that's going to double down the slowing down of the powerhouse, right? The mitochondria. So oxidative stress does that. It damages the membranes. It also causes damage to the fat circulating in the bloodstream, like your cholesterol. And it's going to damage the membranes of the cell and make them less capable of communicating the messages from your hormones. So we get an increase in oxidative stress. So at the end of the day, everything sort of gets primed for the body to store fat. Two other major mechanisms will happen. The other thing is our body can take the glucose that is metabolized into the bloodstream, right? So any carbohydrate content that you're eating in your food, even healthy stuff from broccoli, whatever happens to be derived from that. And one of the ways that we can conserve it is our body, through the enzyme fructokinase, can take that and the polyol pathway, and I had a whole presentation on that on one of the podcasts. So if you want to understand polyol pathway and get super geeky, just go to Menopause Mastery Podcast and look up that podcast. But through that mechanism, our body can take glucose and convert it to fructose in the bloodstream. And what it does is then allow the body preferentially to store that fructose in the liver and other organs as ectopic fat, driving more inflammation, slowing the engine more, driving more weight gain, even if you don't eat it. So even if you're skipping out on all high fructose corn syrup and other forms of purified fructose, your body will still do it. And one of the major mechanisms that drives it too is dehydration. So, because again, the body thinks it's starving, and dehydration is more dangerous than lack of food. So mild dehydration, i.e. you're not getting enough fluid, particularly water, in the body, whether you feel it or not, because by the time you feel dehydration, you're significantly dehydrated. But when you are dehydrated, this fructokinase enzyme kicks into high gear. And so the glucose you have metabolized into the bloodstream, or actually, I guess, absorbed, and that now is in the bloodstream, will get converted to fructose. And this sort of drives this cellular mechanism of fructose comes up, then we get an increase in uric acid inside the cell, and then that slows the powerhouse. So all of that's happening at the cellular function, right? Or if I eat really high uric acid foods or really high sodium foods, right? So the amazing work by Rick Johnson and his team and teams across the world that have looked at that sodium intake and hypertension and this mechanism of uric acid showed that when we eat really salty foods in the face of dehydration, it drives this activity. Or if we are dehydrated. Well, I don't know about you, but I love salt. I have always been like a salt person. I could care less about sugar, but I love salty foods. I love charcuterie. I love olives. I love all those things that drive uric acid up, right? Fermented foods. Those foods I loved. When I started learning all this research and understanding the cellular mechanism and the way estrogen plays into it, I'm not going to talk about that today. I was like, oh my gosh, I have such a cellular mechanics to store fat that it was now starting to come to light. So I hope this is starting to click in for you, right? So now, oh my gosh, my basically in my bloodstream, my body's making fructose anyway, and it's turning on this like fat storage mechanism. Okay. Now I want to touch on the doubling down on the exercise. So if I double down on my exercise, I, hit the Peloton twice a day, or I go to the gym and lift weights, and then I walk, and then I, do some Zumba at night, or whatever I'm doing, is going to drive up my cortisol, right? It's going to drive up my cortisol because too much exercise in the face of starvation drives more starvation. Because again, the body's going to look at that and think you're, crossing the Serengeti looking for food. So the other problem is what we psychologically drive ourselves to do because we want that number to drop, and that's all that matters, right? Let's face it, we all have done it. We look at the number and we're like, dear God, I have this new number that I want in my head, and until I see that number, I'm going to double down if it kills me. Come on, you've said it, I've said it. And so we double down, and then we just make matters worse. So all of that to say, if you're then doubling down on your exercise, you're driving that hormonal effect. And it's really hard when somebody's stuck here because the mechanism to fix this feels so scary that, for our clients, that's why we have health coaches. I mean, we have health coaches for a million reasons, but the health coaches are so important here because we have to work past all of that, story we have in our head and all the stuff we have sort of ingrained in our head that tells us we have to do everything to get to that number, and that, basically deficits and driving starvation is going to be what does it. So we have to rewire our brain while we rewire our metabolism, and we have to refeed, and we have to appropriately refeed. A lot of the times people that go into my hormone reset, part of our intake is to understand kind of where they are on this continuum. And if they have been struggling for a really long time, we often start out with sort of a diet of refeeding appropriately, right? Getting the right nutrients in there in the right combination so the body goes, okay, I'm no longer starving and I need to slowly pull the pedal off of conservation, i.e. storing fat, so I think I'm okay, to then turn around later and correct this underlying metabolic effect. Because it's not something that corrects in a week. Believe me, if I could correct it in a week or 30 days, I would. But even just fuel partitioning, telling the body to sort of shift from being a primary carb burner to a fat burner, in somebody metabolically sound, takes at least 30 days, right? So I'm talking, 20-year-old college athlete, it takes a while for that fuel partitioning to shift. But in somebody who has been overweight and struggling for a really long time, it may take months. Right? It may take several months, but once you fix it, if you keep the habits and things that help keep it flexible, then you can keep it. So what's your take-home message here? So the take-home message is, if you are somebody that has been stuck on a plateau, weight loss resistant, meaning you're not seeing a lot of movement regardless of what kind of version of restriction you're doing, understand that your cells all the way down to the inner RNA, DNA mechanics are working against you to save you. What we dislike about our body is often symptoms of the body trying to do the right thing that you disagree with because of what you see in the mirror. And it starts at the cell. But in order to fix the cell, we have to step back and fix the lifestyle, the diet, the mindset first. And I put lifestyle first because you can't just change your diet and keep everything balls to the wall, crazy, burn the candle at both ends. You can't do that. Believe me, I have tried and it doesn't work. You have to protect your sleep. Because even sleep, even just having mild sleep apnea or upper airway resistance, which is what I had, or having just poor sleep quality will drive that cellular mechanism of metabolic syndrome on its own. Because again, lack of sleep, lack of recovery, the body's not safe, cortisol goes up, the body thinks you're starving, right? So the take-home message is we have to protect our sleep. We have to get sleep, we have to get quality sleep, and we have to make sure that we protect it and that we're getting enough, right? And that means 7 to 8 hours. I know you may be able to operate on 5 or 6, but that doesn't mean you're getting adequate sleep. The other thing is we often have to refeed. So we have to get past the scary restrictive stage and eat more food and reduce the crazy exercise and do more restorative things like restorative yoga, stretching, Pilates, other things that are not as intense, and get off the Peloton bike 6 days a week to help the body understand both cellularly and hormonally that we're no longer in a starvation state. So we have to start eating more and probably doing less restrictive things like long fasting and daily fasting regimens that are significantly restrictive. Because again, in the wrong person in the wrong metabolic state, 16 hours may be too long of a fast. And I have some people that cannot do that without turning on this mechanism. So, if it works for one person and isn't working for you, and you've tried repeatedly, don't keep banging your head against the wall because it's not working for you. And it might be something once we repair your metabolism, we can fix it, but it may not be something you can do right here, right now, right? Because the other part of this is to understand that there's a therapeutic effect of diet change and lifestyle change that is designed to correct the hormonal messages and the cellular messages that your body is getting and giving. And that's a therapeutic diet. And often that may be a stacking of different therapies to help create that metabolic flexibility. And people get scared around that because it feels like either too much, like we're refeeding and they're like, oh my God, I'm afraid I'm just going to gain a huge amount of weight, which doesn't statistically happen, right? Your body gets kind of stuck on a stuck point, doesn't it? It sort of hovers between these pounds, but it doesn't radically go up. Because again, the body if it was calories, it'd be easy. The body is controlling all these mechanisms to sort of keep you there. But we have to get past that scary, like this therapeutic diet is to try and fix the starvation response, right? Might be eating more. And then once we have that corrected, then we do a different therapeutic response to create the metabolic flexibility where the body can partition the different fuels it's using between fat and sugar and using amino acids properly. And then we get to the maintenance phase where we integrate all of those things based on your genetics and where you are in your time period of life and your hormones and all that other stuff, where you don't have to continue to be restrictive. Because I can tell you, I don't want to eat low carb, high protein, never touch a carbohydrate in my life again. At 53, I'm done being that restrictive. I just don't want to live there. Now, if I was doing something because of a health condition, that's different. But I don't want to do it just because I don't like the size of my ass. Right? I'm not willing to waste that much energy, effort, or emotion on it. I have bigger things that I want to do in my life. Right? So the take-home message here too is there's a method and an effect that has to happen if you're stuck here. We can check it. We check it on labs. We can see what's happening. Right? So where somebody is on this continuum, so we know number one, what does the refeed look like? B, what does the reset look like on the cellular mechanics and metabolism to create metabolic flexibility? And then what is your personalized maintenance? Because that's what I was able to do with myself and hundreds of other clients because we figured out that sort of mechanism and then how to sort of fix it. I went back to school to get my PhD, so you don't have to. How about that? All right, so the take-home message here is if you are stuck, you are stuck. And it's not because you haven't doubled down and tried. It's because your body's trying to save you. And that there is a way to fix this. There are mechanisms to fix it. It's just you've got to go through the right process. So I hope you found this to be an enlightening conversation about weight loss resistance. And particularly, this is always worse when we're over 40 women. We have a whole bunch of cellular things that just exacerbate this. But it can be fixed. Right. So thank you everybody for listening to Menopause Mastery. If you found this to be helpful in any way, I'd love it if you could leave me a review. Even if you didn't like it, I want to read that too. So I'd love to know that. Share it with your friends because I do this as a labor of love and I want to help women understand their bodies and the partners that love them if they listen. I want you to really feel empowered so you can live the next best season. Have a great week and I will see you next week. Thank you so much for tuning in to the Menopause Mastery podcast. You are why I'm here, and I am so very grateful. Hit subscribe so you don't miss any wisdom on creating the most exceptional life on our terms. If this episode has helped you in any way, please share it with a friend to spread the love, and together we rise. You can follow me on social media at Betty Murray, PhD, and you can reach me online at bettymurray.com.